All right, so we are looking at page 203, and we're going to go over some more solving of equations. So if we look here, we kind of have the steps for solving rational equations. So we factor all the denominators, find the common denominator between all of them, make every term have that common denominator, and then once all of our denominators are the same, we can solve the numerator for x and then check for extraneous solutions. So the big thing in these notes, we've seen solving rational equations before, but the big thing in these notes is we have just a number somewhere that we need to know what to do with. So if you remember, anytime we have a number and we're trying to turn it into a fraction, so let's say we had something like 4/9 plus 2, we would want to put a 1 underneath to make it turn into a fraction. 2/1 is still the value 2. So you're not changing the value of the fraction or the number, you're just turning it into a fraction. So we would do the same thing here. We would write this as 5/1. So then as we think about all of our numbers and making this a common denominator, we know that our denominator would need a 2 in it. Since this has a 2 in the denominator, your common denominator will need a 2 in it. This fraction has an x in it, so that means your common denominator would need to have an x in it. And then this denominator has a 1. Well, technically, this has a 1 in it, right? 1 times 2 is 2. So this already has the component of a 1x in it. You could think of this as 2 times x times 1, but 2x times 1 is still just 2x. So this is the common denominator I need all of my fractions to have. So then we're going to go through and figure out what each fraction needs in order to get that common denominator. So for instance, if we look at the first fraction, it already has the 2, but it's going to need an x. So I'm going to multiply the top and the bottom by x. So that will give me x times x, which is x squared over 2x. Then if we look at our second fraction, again, we already have part of the common denominator. We already have the x, but we're going to need the 2. So we're going to multiply the top and the bottom by 2. So 2 times 12 would give me 24 over 2x. And then the last fraction only has a 1, so that means it needs all of this. So I'm going to multiply the top and the bottom by 2x. So 5 times 2x would give me 10x. 1 times 2x would give me 2x. So now I have multiplied each fraction so that all of my denominators are the same. And so now once we have all of them have this denominator, we can just set the numerator equal and solve. So we're going to solve x squared plus 24 equals 10x. So then if we think about how we would solve with an x squared, we would want to try to factor this. So we're going to bring this 10x over to the other side. So I have x squared minus 10x plus 24 equals 0. So then if I try to factor that, what multiplies to give me 24 and adds to give me negative 10 would be negative 4 and negative 6, which means if I set x minus 4 equal to 0 and x minus 6 equal to 0, I get x equals 4 and x equals 6. And then the last step would be to check for extraneous solutions. So would plugging in either of these numbers create a denominator of 0? So this wouldn't be a denominator of 0. X is 4, that's not 0. And this was 1. So none of these are going to create 6 here, would not make 0. So neither of these would make a denominator of 0, meaning both of these are solutions. So just like we looked at week 1, the goal is to get everything to have a common denominator, and then we're just solving the numerator. So if we look at our next example here, I have no denominator here. So again, this is where I would put a 1 underneath to make it so that it has a denominator. So then this has a denominator of x plus 4, meaning my common denominator would need an x plus 4. Then this has a denominator of 1. So again, if I put a 1 in front of here, like 1 times x plus 4, that's not going to change the value of x plus 4, right? 1 times x is 1x, 1 times 4 is 4. So multiplying by 1 does not do anything to my common denominator. And then this is an x plus 4, which I already have as part of my common denominator. So really, I just want all of my denominators to have an x plus 4 in it. So this one already has an x plus 4, so I don't need to change this first fraction. Now my second fraction only had that 1 underneath, so it needs to have the entire x plus 4. So I'm going to multiply the top and the bottom by x plus 4. So I have 3 times x plus 4 over x plus 4, right? Anything you put the 1 underneath is going to need all the different components to the common denominator because it only has a 1 right now. And then my last one already has the x plus 4, so I can just leave it as 4 over x plus 4. So really all of mine now have the same denominator, right? These already had the x plus 4, so they stayed the same. So I just had to take that number, which I had turned into the fraction 3 over 1, and get that common denominator. So now that all my denominators are the same, I can ignore them and then solve the numerator. So I have 3x plus 12 minus 4. So then if I combine like terms, I have x equals 3x plus 8 if I combine these two together. And then to solve, I'm going to need my x's on the same side. So I'm going to bring these x's over here. So x minus 3x would give me negative 2x equals 8. So when I divide by negative 2, I get x equals negative 4. So then if I check for extraneous solutions, if I put negative 4 here, negative 4 plus 4 gives me 0. That would give me a 0 in the denominator, which we do not want. So that means this is an extraneous solution. And this problem here actually has no solution, right? If I ever get a denominator of 0, that is an extraneous solution. So then there is no solution to this problem. All right, let's do a couple more together. So here, again, I have just a whole term. There's no fraction, so I want to turn it into a fraction. So to do that, we're always going to put it over 1, right? Putting something over 1 does not change the value of the number. It just turns it into a fraction. So now if I want to find my common denominator, remember 1 is not really going to contribute anything to the common denominator. So I don't have to worry about the 1. Both of these have an x minus 3, so that means that my common denominator needs to be x minus 3. So my first fraction, this x over 1, to have a common denominator of x minus 3, I need to multiply the top and the bottom by x minus 3. So I have x times x minus 3 over x minus 3. When I simplify that, right, I'm going to multiply x and x minus 3 together, and then 1 times x minus 3 is just x minus 3. Then both of these already have the common denominator, so I don't need to change anything about them. They can stay exactly the same, and now all my denominators match. So then when all of my denominators match, I'm just solving the numerator. So I have x times x minus 3 plus 6 equals 2x. So if I start by distributing, I have x squared minus 3x plus 6 equals 2x. So then because it's a squared, I'm going to bring everything over to factor it. So I'm going to subtract 2x from both sides. So then I have x squared minus 5x plus 6 equals 0, which would factor to x minus 2 times x minus 3, right? What multiplies to give me a positive 6, and a negative 5 would need to be negative 2 and negative 3. So when I set both of those equal to 0 to solve for x, I get x equals 2 and x equals 3. So I factored and then I solved my factors by setting them equal to 0. And so now if I check for extraneous solutions, if I plug 2 in here, I have 2 minus 3, which is negative 1. I'm perfectly fine with having negative 1 as a denominator. If I plug in 3 here, 3 minus 3 would give me 0. So then I can't have that. So then that means my only solution here is x equals 2. All right, so then moving on to the next one. So this is the first time we're actually going to have to do step 1 of our notes, right? Before, there was nothing to factor in any of my denominators. Here, I can factor this, right? So I'm going to put a 1 underneath this so that this becomes the fraction, right? I need all of them to be fractions in order to solve. I can't ignore, if I'm going to have them all have a common denominator, that means that they all have to have a denominator. I can't ignore the fact that this doesn't have a denominator and just set the top equal to 2 because it doesn't have the common denominator right now. So then if I factor this, x squared minus 4 factors to x plus 2x minus 2. So then if I think about my common denominator, this one has an x minus 2, so my common denominator needs to have an x minus 2. This one has an x plus 2 and an x minus 2. Well, my common denominator already has the x minus 2, so I just need to attach the x plus 2 as well. And then again, 1 is not going to really contribute anything to your common denominator. So now I need x minus 2x plus 2 to be the denominator of all of my fractions. So the first one already has the x minus 2, so it's just going to need the x plus 2. So then I have 4 times x plus 2 over x plus 2, x minus 2. The second fraction already has both pieces, right? It already has x plus 2 and x minus 2. So then it's going to stay exactly the same. And then my second fraction doesn't have either of them. Right now it's just 2 over 1. So I'm going to have to multiply by x minus 2 and x plus 2. Now, to help us multiply, to make this simpler, we already know what happens when we FOIL this. Right? Since I need to multiply by both of them, I'm essentially going to have to FOIL them, but I can do that later if that is easier, right? I need it. So now all of my denominators are the same, so I can ignore them, and I'm just going to solve the numerator. So I have 4 times x plus 2 plus 14 equals 2 times x minus 2, x plus 2. So first we're going to want to multiply everything out. So if I multiply this, I get 4x plus 8 plus 14, and then I'm going to FOIL this out first before I multiply in the 2. So I would have x squared plus 2x minus 4, which we knew that those two would make x squared minus 4 because that's what we factored it out to be. So then I have 2 times x squared minus 4, which would give me 2x squared minus 8 equals 4x plus 8 plus 14. So then if I continue on to simplify, I'm going to give myself some more room. When I combine like terms, I have 4x plus 8 and 14 make 22 equals 2x squared minus 8. So then I want to bring everything to the same side. So I'll subtract 4x and subtract 22. So I have 2x squared minus 2x minus 30. Minus 4x, sorry, I knew something was wrong. Right, I subtracted 4x, so I have 2x squared minus 4x minus 30 when I combine my like terms equals 0. So now I want to factor this. The first thing we should look for, and we should always notice, is could I divide out a GCF? So here I could divide out a 2. So then I have x squared minus 2x minus 15, which is much easier to factor when I divide out that 2. So we always want to look to see if a GCF will divide out to simplify our problem. So then factoring x squared minus 2x minus 15 would be x minus 5 times x plus 3. So then, because this doesn't have an x value in it, there's not going to be a solution out of this 2. If I set 2 equal to 0, that's not true, so that's not going to give us an answer. So really all I want to do is set these factors equal to 0 to solve for x. Right? I factored out the 2, so I kept it in the front, but when it comes to solving, that's not going to produce an answer for us. So then I get that x equals 5 and x equals negative 3. And then if I go back to my original problem, plugging in a 5 would give me 5 minus 2, which is 3. That's fine. I can have 3 in the denominator. And then 5 squared is 25 minus 4 is 21. So 5 does not give us a 0 in the denominator. Negative 3 minus 2 would give me negative 5. Negative 3 squared is 9. Minus 4 is 5. So negative 3 also would not give me 0 in the denominator. So I can keep both of those answers. All right, so now would be a good time to pause the video and try the next two on your own. So pause them, give them a try, and then come back and we'll go over them together. So if you pause the video and try these, we'll just go over it to see how you did. So remember, the first thing we want to do is make sure all of our terms are fractions. We would write this over 1. Then I want to factor everything to see what factors I have at the bottom. So x squared minus 5x minus 66 would factor to x minus 11 times x plus 6. So now when I figure out my common denominator, right, this fraction has x minus 11 already, so my common denominator would need an x minus 11. 1 is not going to do anything for us. Here I have an x minus 11 and an x plus 6. Well, my common denominator already has this x minus 11, so I would just need to add the x plus 6 as part of the common denominator. So now I need all of my fractions to have these two factors in the denominator. So my first one has the x minus 11, so that means it just needs the x plus 6. So I multiply the top and the bottom by x plus 6. So I'd have x times x plus 6 over x plus 6 times x minus 11. Right, I just rewrote that to put the x in the front, but essentially I'm just multiplying x times x plus 6. Then my second fraction is going to need both of them. Instead of writing them out in factored form at the top, I already know what these two are when they're in standard form, right? This is what it came from. So instead of multiplying the top by x minus 11, x plus 6, and having to multiply it out later, right? If I multiply these out, I get x squared minus 5x minus 66. So to save myself the multiplying later, I'm just going to write this as x squared minus 5x minus 66. And then I'll keep it in factored form at the bottom just so it looks the same as all my other denominators. And then again, this already includes both common denominators, so then I can keep this as 22 over x minus 11, x plus 6. So by foiling this out at the beginning, it just saved us from having to, or knowing that this foils to this and writing this out instead is just saving us the step of multiplying, right? So now all of my denominators are the same. So I'm just solving x times x plus 6 minus 1 times x squared minus 5x minus 66 equals 22. So then when I distribute, I have x squared plus 6x minus x squared plus 5x plus 66 equals 22. So my x squared and my negative x squared would cancel. Combining my like terms, 6x and 5x would make 11x plus 66 equals 22. So I subtract 66 from both sides, and 11x equals negative 44. So I get x equals negative 4. And then if I look here, because my factors are x minus 11 and x plus 6, I know a negative 4 is not going to make one of those 0. The only two numbers I'm really concerned about here would be if I got a positive 11 or a negative 6. Those two would make a denominator of 0, so negative 4 is completely fine. So then looking at the last one again, I'm going to make all of my fractions first be fractions, have denominators. Then I'm going to factor this out to figure out what my denominators are made of. So x squared plus 2x minus 3 would factor to x plus 3 times x minus 1. So my common denominator would be x plus 3 and x minus 1. Right, if you think about this this has an x plus 3 that's in my common denominator. We don't consider 1 when making a common denominator because putting a 1 in the front wouldn't change any values. And then both of these are now part of that common denominator. So now I'm going to make sure I'm going to multiply every fraction so that every term has the common denominator. So this already had the x plus 3, so that means it needs the x minus 1 at the top and the bottom. So that means I have x minus 1 times x plus 2 over x minus 1 times x plus 3. Then again, to save yourself the hassle, you know that these two multiplied together is x squared plus 2x minus 3. So instead of writing it in factored form, write it in standard form, and that saves you a step at the top. It'll save you some multiplying. And then that's x plus 3 times x minus 1. And then the last fraction already has both, so I just keep it as negative 1 over x plus 3 times x minus 1. If you want to write this in factored form at the top, that's fine. You're just saving yourself a step from multiplying later because you are going to have to multiply both terms together and you get x squared plus 2x minus 3. So I'm just kind of saving a step through the process. So now all my denominators are the same. So now I'm just going to solve my numerators. So I have x minus 1 times x plus 2 minus 1 times x squared plus 2x minus 3 equals negative 1. So I'll have to FOIL this out. So I have x squared plus 2x minus 1x minus 2. I'll distribute this minus 1x squared minus 2x plus 3 equals negative 1. So then my positive x squared and my negative x squared will cancel. I could also cancel my positive 2x with my negative 2x. So then I have negative 1x. Negative 2 plus 3 would give me positive 1 equals negative 1. And now I'm just solving my equation for x. So I'll subtract 1 on both sides. Negative 1x equals negative 2. Divide both sides by negative 1. I get x equals positive 2. And then if I plug those into my denominators, 2 plus 3 is 5, so that's fine. Here, if I plug a 2 in here, that's 5. I plug a 2 in here, that's 1. 5 times 1 is 5, so I'm fine with 2 being one of my answers. I would not be okay with -3 or +1, but that's not what I got, so my answer would be x equals 2. So hopefully this helps you as we continue practice solving, and you can complete your homework.